Hello guys and girls, welcome to a new clip in the C# for Beginners playlist. In this one we are going to talk about the second pillar of object-oriented programming, inheritance. And you can think of it like this. Since OOP is all about emulating the real world, which contains objects that have properties and behaviors, we also need a way to emulate the concept of inheritance, which for example is present in a cat by simply the fact that it inherits the properties and behaviors of a broader group of felines, which itself inherits from a broader group of mammals, which inherits from a broader group of animals, and so on. And we can do that like this in code. We have two classes, bird and cat, and each type of animal has behavior specific to that class of animal. Like for example, a cat can purr but can't fly, and a bird can fly but can't purr. But also, both cat and bird have properties that are common, like for example, a name and a weight, and they also have common behaviors like sleeping. In fact, any kind of animal has the behavior of sleeping, and they all have a name and a weight. So instead of duplicating that code in every single class of animal that we will ever create, we can create another dedicated class called animal, which contains all these common behaviors and properties, and then we inherit it. Meaning we use this semicolon character, which reads as class cat that inherits from class animal, class bird that inherits from class animal. And basically this means that the class cat and bird also receive everything that is inside this animal class, as if the behavior and properties were also part of the cat or bird. In this context, the animal class is called a base class, a parent class, or a superclass, whichever you prefer, and cat and bird are called derived classes or child classes. And we can use them in the traditional sense that we've been using classes all along. We have two classes, two instances, cat and bird, and we can see the common behavior of sleeping in both of them, even though again there is no sleep method in either cat or bird. But we also see the individual behaviors of purring in cats and flying in birds, because it is obviously present in those classes. So the common behavior, the sleeping, is there because we are inheriting. Cat inherits from animal and receives the public sleep method. You will often hear about the is-a relationship in regards to inheritance. That is, a cat is an animal. It's also an animal. So when you inherit a class, you also become that class. That means I can do this. I declare a variable of type animal, and even though it is of type animal, I am allowed to assign an instance of type cat to it. Why? Because a cat inheriting from animal is also an animal. It contains everything an animal has. So when I declare a variable of type cat, that is a very specific kind of animal. It contains everything an animal has, but it also contains the very specific behavior of a cat, like purring. On the other hand, when I declare a variable of type animal, that is a very generic type of animal. It can be a cat, yes, but it also can be a bird or any other type of animal. That means that I can do this. So you can see that I am allowed to call the sleep method just fine because it is present in every single animal, but I'm no longer able to call purr even though I assign a cat instance to this animal. Because even though internally it does still contain the purr method, the compiler doesn't see it. I am assigning this cat to a group of animal, a broader variable, and that means that I'm losing this specific behavior of a cat. In order to be able to see it again, we need to do a manual explicit cast back from a generic animal to a specific cat, like this. So I am casting my animal variable back to a cat, and that allows me to call the purr method. But beware that since I am allowed to cast it back to anything, I can also do this. So this will not work, obviously. I'm getting an exception because I'm trying to cast an animal to which I initialized it with an instance of type cat to a bird, which theoretically would allow me to call the fly method on it, but this crashes because obviously the new instance of cat that I placed inside this animal is not a bird, so I cannot cast it to a bird. So you need to be careful about that. In this context, C# offers us two very important operators, is and as. Is checks if a type is another type. As tries to convert one type into another type. So we can do this. Where I am first using the is operator to check if my animal variable is of type cat, and only when it is, I am performing the actual casting with the as operator. The difference between as and explicit casting is if my animal variable is not of the type I'm trying to explicitly cast, I will get an exception like you just saw, but in the case of the as operator, I will only get a null value in return. That's also the reason why I get this warning that tells me that I'm trying to convert a null literal or possible null value to a non-nullable type. I explained all this in the nullability video. If you don't know what I'm talking about, go watch it. So I'm converting with the as operator back to a cat, which allows me to call methods that only a cat possess. Because this combination of the is checking first if the something is of type something and then casting with the as is so common, we also have a simplified syntax like this. And in this case, other cat, this variable, will only be populated if the animal is of type cat. So first the check is performed, and if it succeeds, it's also casting it back in this variable, which then I can use. Access modifiers and encapsulation still applies to inheritance too. So if a member is declared as private, it is only visible in the classes declared in, not in inheriting classes. And in fact, when I talked about access modifiers, I said that two of them are related to inheritance, protected and protected internal. Protected means that a member is visible in the class is declared in, plus any inheriting child classes. Protected internal means it's visible everywhere in the current assembly, plus any inheriting classes, even if they are declared in other assemblies, other C# projects. Sometimes you want your classes not to be inheritable. For that, we have the sealed keyword, which means this won't work. Because I declare some class as sealed, I cannot inherit it. And in fact, I do consider it a flaw of the language design, the fact that it's opt-out when it should have been the other way around, disable by default and have some keyword to explicitly opt-in for any classes, only for the classes that should be inheritable. Also, base classes can have parameters with mandatory parameters, in which case the child classes also must ask for those parameters in their constructors and forward them to the base class using the base keyword like this. So I have a base class called vehicle, which in its constructor has a single constructor with a mandatory parameter asked for a boolean. So when I'm inheriting this class, I also must generate a constructor for this child class that asks for a parameter of the same type and forward it using the base keyword towards the parent class. And the base keyword is not usable only in the context of the constructor. Base means the parent class. I can call anything that is accessible on the parent class with the base keyword. For example, in the cat example, we could have said something like base.sleep to call the sleep method inside the animal class. Unlike C++, C# only allows inheriting from a single class, which means if I want to inherit multiple classes, I can only do it in a hierarchical manner. Class A that inherits class B, that inherits class C, and so on, something like this. So in this case, I have a problem. What if I want A to inherit from B, but not from C? I can't, because B inherits from C, so when I inherit B, I also get the traits of C, whether I want to or not. And this is why hierarchical inheritance is very rigid. And that's also the reason why you will hear that inheritance should be avoided, and instead you should be using composition, something like this. We have three classes, x, y, and z, and then we have another class, w, which has a constructor where it asks for two parameters, x and z, and then it saves them in read-only fields for later use. But the idea is, in the constructor, I can ask for any kind of parameter that I want in any combination I want. I can ask for x and z, I can ask for z, I can ask only for x, I can ask for, I don't know, y, and so on. So this is composition. I ask in the constructor whatever I want in this class, in the combination that I want, and it's basically composing this class. And unlike earlier with inheritance where we had an is a relationship, this is a has a relationship. The class W has a x, has a z component. Even though C# doesn't allow multiple inheritance, it allows implementing multiple interfaces, which more or less achieve the same end result. But we haven't learned about interfaces yet, so this will make much more sense when we will. You should also know that in .NET there is a base class called object, which if I navigate to the definition of, we will see that it contains stuff like get hash code, toString, and others. Now, this is basically the base class of any data type in C#. So, for example, if I declare an int and I type age dot, I will have methods like get hash code and toString, the methods that we just saw in the object. Even though int doesn't explicitly inherit from object, as you can see, somehow any data type, whether you manually inherit from object or not, ultimately gets to inherit from object. So you could say that object is the parent of all data types in C#. So that was it for today. In the next lesson we will learn about virtual methods, which sound quite intriguing. Anyway, if this lesson was of any help to you, don't forget to like and subscribe because it helps this channel to grow. And until next time, thanks for watching, and I'll see you in the next episode.